Hi, I'm Alexander and I'm going to give you a brief tutorial on how to use CytoITMprobe, a Cytoscape plugin for analysis of information flow in networks. I'll leave the details about the inner workings of ITMprobe for another time and here focus on the most common usage patterns. Here is the Cytoscape desktop, where I have loaded a yeast protein-protein interaction network. This network contains about 4,200 nodes and about 24,000 edges. We first need to load the CytoITMprobe plugin and get the query form. Go to the Plugins menu, find CytoITMprobe and click on the query form item. As you can see, the query form just appeared in the Cytoscape control panel. We have to resize the control panel in order to see the entire query form. In this tutorial, I will show you how to run a normalized channel model query. I'm assuming that you're using the default configuration where CytoITMprobe sends remote queries to the ITMprobe web server. To run a query, we need to set a query network and the context. My example network is already selected, but I need also to decide what edges should be treated as directed, undirected, or ignored. This network has only two edge types, U and D. They are originally placed in the undirected box, but can be moved to other boxes. If you want to treat an edge type D as directed, select it and move it to the directed box using the right arrow button. To ignore it, just move it to the ignored box using, again, the right arrow button. In this case, we will treat D edges as directed and U edges as undirected. We also need to specify the weights of the edges. This is done through the Cytoscape edge attributes. As we can see, this network does not have any floating point attributes. If it did, we would have been able to use the values of that attribute as edge weights by selecting it in the weight attribute drop-down box. In this case, the only choice is the default. It assigns the weight 1 for each undirected edge and weight 2 for each directed edge. Now, I need to set up the context for the normalized channel model. The normalized channel model requires me to set at least one source and one sink, as well as a dissipation criterion. It also allows me to provide a list of nodes to exclude from the query. Sources and sinks are specified by selecting them in the network and pressing the plus button next to the appropriate box. The yeast network I am using for this example is quite large, so I need to use the Cytoscape search box to locate the desired nodes. I'll type here the name of my first source, ALP3. This gives me one hit, and that is exactly the node I need. I'm going to click plus, and it appears in the sources box. Similarly, I'm inserting the second source, GCN5. In the same way, I'll insert my third source, HAT1. I'm also going to insert two sinks. The first one is RPO21. I'll click plus next to the sinks box and it'll appear there. Note that the node IDs appear in the sources and sinks boxes rather than the canonical names, but we can easily go from one to the other in Cytoscape. The next sink is POL2. I now have all my desired sources and sinks. I'm going to leave the dissipation criterion to the default probability of 0.15. Before I start the query, I also need to set a list of excluded nodes. These are the nodes that could provide the shortcuts for information flow and influence the results in a bad way. You may have a file listing the nodes that you want to exclude, which can be loaded using this button. I'll load mine now. You can also insert excluded nodes in the same way as sources and sinks. I'm now ready to run a query, so I'll click on the Run button. And here are the results. We now have a new network titled ITMprobe Query ITMC003. On the right, the Cytoscape results panel has appeared with a single tab titled also ITMC003. Within that tab, there are more tabs that we will discuss later. ITMC003 is the label for our query. ITM stands for Information Transduction Module, C is a label for normalized channel mode, and 003 is a counter that runs from 0 to 999 before resetting. Thus, we are able to distinguish between different queries. The ITM network contains the nodes from the original network that are the most relevant in the query context. Its appearance is controlled through the Display Options form, which is a part of the corresponding Results panel tab. Let me point out that we can close the ITM tab in the Results panel by clicking here on the Close button. This also destroys the ITM network. Have we lost our results? No, because they are actually stored as node attributes of the original network. So we can load them by clicking on Load. A list has now appeared with only one item. We click OK, and the same network reappears. If we had ran several ITMprobe queries, they would all be stored under the original network, and we would have been able to load them in this way as well. This also means that if I saved the original network with its attributes in Cytoscape, say as a session using save as or in some other way, I would have been able to later restore all the query results and their viewers using the load button in the query form. Let's now focus on the tab in the results panel. We first see the Display Options tab with the rendering form. I've already explained what the Close button does. Before explaining this form in more detail, I'm going to first describe the other sub-tabs. The first one is titled Top Scoring Nodes. It shows us the results for the nodes displayed in the ITM network. The values for all result attributes are shown here. Then there is the Summary sub-tab, which contains a list of the summary quantities for the entire query. The Input Parameters sub-tab echoes the main query parameters, while the Excluded Nodes part shows what nodes were excluded for this query. The last three tabs do not change if different display options are set. We now go back to the Display Options form. It has two parts. The top Node Selection Options determines what nodes are shown in the ITM network and in the top scoring nodes table. The Node Coloring Options determine how the nodes in the ITM network are colored. I'll first go over the coloring options. Here, as you can see, Total Visits is selected as the default coloring attribute for our ITM graph. The second item is Scaling, which determines how the values of the coloring attribute are transformed into color values. I recommend you stay with the default, which in this case is the logarithmic scaling. The Color Map drop-down box offers a choice of the coloring schemes that can be used, such as blues, reds, grays, and a few others. Alright, let's see what happens if I change the coloring attribute to visits from ELP3 and the color map to reds. I need to click the Render button to see the changes. We now see only the flow from ELP3 highlighted. I need to zoom in a little closer now. Note here that in the ITM network, hexagons always indicate the sources, octagons the sinks, while other nodes are either rectangles or ovals. Ovals represent self-adjacent nodes, since the ITM network does not show edges with the same source and destination. I can also display up to 3 flows, that is attributes, at the same time. To do so, I need to select all the desired items simultaneously in the coloring attributes list, and then click Render. What we see now is the color mixture mode. Each attribute gets assigned a basic color, cyan, yellow, or magenta, and the color of each node is obtained by mixing the basic colors in proportion to the corresponding flows. This view is very useful as the summary of the query results. Finally, we'll explore the node selection options. The main idea here is that the ITM network, and as we have seen, the top scoring nodes table, contains only the most important nodes. The nodes are ranked using the ranking attribute, and the total number of top scoring nodes shown is determined by the selection criterion. And there are 3 selection criteria that can be chosen. Participation ratio uses a formula to determine the number of significant nodes, and that number is then used for displaying. The other option is to use a cutoff value specified in this box and take all nodes that have the ranking attribute greater than that value. Finally, we can choose to display a fixed number of nodes using the maximum nodes option. Note that the number entered in the maximum nodes shown box overrides the numbers determined by the participation ratio or the cutoff, if these are greater. As an example, I will now select visits from L3 as my ranking attribute and display exactly 70 nodes. Crowded, isn't it? This ends the CytoITMprobe tutorial. I have only covered the most basic operations. For more detailed instructions and pointers, please visit the ITMprobe website.